All right, so you've just perfected how to take out a GCF. All right, that's called factoring out a GCF. I think we're okay with that now, all right? But what happens if there isn't a GCF? Like, can it still be factored if I can't divide something out? So if I look at this right here, well, I've got 3 terms. So really, like, what I'm looking to find is the GCF between 1, 2, and 24. So if I was using my calculator and I like math, arrow to the right 9, I would do like the GCD between 1 and 2, because remember, I can't use the negative. And if I do that, the calculator is going to spit out a 1. And then if I take that GCF, which is 1, and I pair it with the 24, and I'm just going to get a 1. And we talked about how 1 is not a GCF. Everything can divide by 1. If I were to divide each of these things by 1, I'd still get the same thing. And then because this doesn't have an x, then there's no variable GCF, right? So I can't divide an x out of everything because the last term doesn't have an x, all right? So the numbers don't have a GCF because the only thing they have in common is 1, and the x's don't have anything in common because the last term doesn't have an x. So there's no GCF here. If there's no GCF, that doesn't mean it can't be factored. It means it can't be factored using the GCF method. But there are 4 different factoring methods. You're going to learn all 4. You've learned 1. The first factoring method that you should always try, which is why we did it first, is GCF. If you can do a GCF, that is the factoring method you need to use, right? If that doesn't work, the second method you try, we're going to call it the A equals 1 method. And there's a reason for that, okay? So we're going to today factor using the A equals 1 method. When GCF doesn't work, your next best case scenario would be the A equals 1 method, right? So when do we use it and how do we use it? We're going to do that in our toolkits. So go to toolkit page 6. To use the A equals 1 method, you got to have a little bit of number sense. The A equals 1 method is kind of like solving a puzzle. And in that puzzle, you're going to be doing multiplication and addition. Finding numbers that multiply to this and add to this, which means we got to have a little bit of number sense. So we're just going to review some real basic multiplication that you learned in 3rd grade, because my son is learning multiplication right now, okay? So it's been a while. You know this stuff, all right? So let's think about what happens when we multiply 2 positive numbers. A positive times a positive. Think about 2 positive numbers in your head. 3 times 2. The outcome of that is positive, all right? So a positive number times a positive number is another positive number. All right, let's think about when we multiply 2 negatives. Think about 2 negatives in your head. -6 times -5. Positive, right? A negative times a negative is a positive. All right, what about if the signs are opposite? +4 times -7. Negative, all right? So a positive times a negative is a negative. All right, so that's all multiplication. We know that, okay? We're going to use that idea in what we do next. Now, what about addition? Think of a positive plus a positive. 5 plus 5. Is that a positive outcome? It's 10, right? It's positive, so this is positive. What about a negative plus a negative? -3 plus -4 is -7, right? At -3 and then another negative. When you add 2 negative numbers, it's negative. That's different. Multiplying negatives gives you a positive, but adding negatives gives you a negative. So keep that in mind. What about positive plus a negative?
Oh.
Depends, right? This one's going to depend on which one's bigger. If the positive number's bigger, then it's a positive. If the negative number's bigger, then it's a negative. So that one's going to depend. All right. So that one could get a little complicated, a little tricky. All right, so we're going to come back to this as we do these problems today. So in your toolkit, continuing on this page, is how to factor a trinomial of x squared plus bx plus c. You're going to hear me refer to this as the a equals 1 method, okay? In order to use the a equals 1 method, it has to be a trinomial. What does that mean? What is trinomial? It has to be 3 numbers. If it's 2 numbers, I cannot do this. It won't work, okay? And of those 3 numbers, we're going to think of them as A, B, C in order, right? So this is A for the first example. This is B, and this is C. Well, what number's in front of this what's the coefficient of x squared? What number is that? A equals 1, B equals 8, C equals 15. So it has to be a trinomial, and the A term, the leading coefficient, the first number you read is a 1. If that was a 4x squared, you can't use the A equals 1 method because A is 4. Does that make sense? So 2 things need to be true. It's got to be a trinomial, 3 terms, and the first term's got to be 1. If I have those things to be true, then this is my method. This is what I'm going to do. All right? Step 1, check for a GCF between the coefficients and variables. If there is one, factor it out. So you can do that in your head, or you can use math arrow to the right 9. And you could do the GCD of the leading coefficient and the second term, because I can only do two terms at a time. So I want to check for a GCF between 1 and 8. And if you type that into your calculator, you're going to get a 1. And then I take that GCF and I compare it to my last number, and again, you're going to get a 1. And 1 is not a GCF. Okay, so in terms of numbers, there's nothing I can divide out. And because this has no x, then there's no variable GCF either. Your first step has got to be to check for a GCF. Because if there is one, you've got to divide it out. But there isn't one here, right? If I map arrow to the right 9 and I check the coefficients, 1, 8, and 15 have nothing in common. All right, if you listed out the factors of 8, 1, 2, and 4, and you listed out the factors of 15, 1, 3, and 5, the only thing they have in common is 1. 1's not a GCF. They don't all have x's, so there's no x GCF. There's no GCF. So then I go to the next step. I'm going to type the c value divided by x into the y equals screen. So in my y equals screen, I'm going to do the c value. The c value in this case is 15. All right? It's the last number. And you don't even have to use your calculator if you don't want to, right? But in my y equals screen, I'm going to do c divided by x, and I'm going to look at the table. Right? I'm going to start with 1, right? That's the first value in the table, and next to that is a 15. Next to the 2, if you look in your table, will be a decimal, so I'm not going to write that one. Next to the 3 is a 5. Next to the 4 is a decimal. Next to the 5 is a 3, but really that's a repeat. I'm just swapping my numbers there. So I'm not even going to write that one. It's a repeat. Once you start to get the repeat numbers, you know you're done your list. Okay? So what I am looking at are the factors of C, which is 15. So step 2, type the C values divided by x into the y equals screen, then hit second graph. So here's my table. Look for the numbers in the table that are next to each other that add to the B value. Remember, the B value is the second number. What's the B value in this? 8. Okay. I am looking for these things to add to 8. So look what happens if I add these together. 1 plus 15 is 16, and 3 plus 5 is 8. You want to pick a pair of the numbers next to each other. You want to make sure that pair is the pair that adds to the middle number. Everybody okay so far? So my pair is 3 and 5. I know I'm using 3 and 5. So step 4, put those numbers in the blanks. So I've got blanks here. See, like the format is like parenthesis x blank, parenthesis x blank. 2 parentheses next to each other. In the blank, I'm going to put the numbers. Now, because the 3 and the 5 in the table are both positive 3 and 5, I'm going to put plus. But eventually we'll work with some negatives and we'll make them minus. The order that you put the numbers doesn't matter. It doesn't have to be smaller first, bigger second. You could put the 5 first. Check your answers by typing the question into Y1, the x squared plus 8x plus 15 into Y1, and the x plus 3, x plus 5 into Y2. That's one way to check it. Another way to check it is to distribute x times x plus 5 and positive 3 times x plus 5. Redistribute. Remember, when we multiply, we add. So x times x is x squared. X times 5 is 5x. 3 times x is 3x. 3 times 5 is 15. And when we combine like terms, 5 plus 3 gets us right back to where we started. All right, so you could redistribute or you could use Y1, Y2. All right, so my answer for this one is called factored form. This is my factored form. X plus 3, x plus 5. All right, let's try another one. Again, this is called A equals 1 method. The reason it's called A equals 1 is if I were to call the coefficients of these numbers A, B, and C, the leading number is 1. So A is 1. B is negative 11. The minus sign goes with it. C is 24. It's the A equals 1 method when your first value is 1. Remember, I can only do this for trinomials. I need an A, B, and C for this to work. If I just have an A and B, it's not going to work. All right? So we need to check for a GCF between the coefficients and variables. If there is one, we're going to factor it out. But there's not, because 1 and 11 only share one number in common, which is 1. 11 and 24 only share one number in common, which is 1. 1 isn't a GCF. And the last number doesn't have an x, so there's no x GCF. There's no GCF with these numbers. There's nothing to divide out. So the next thing I'm going to do is I'm going to type the C value divided by x into my y equals screen. So in my y equals screen, I'm going to do 24 divided by x. And when I go to my table, I'm going to be looking at numbers that multiply together to be 24. You okay with that? But I also need the numbers to add together to be the B number. So let's think about what we know. I need the numbers to multiply together to be a positive, but add together to be a negative. What types of numbers multiply together to be a positive, but add together to be a negative? Two negative numbers. So this is where your number sense comes in. Because right now, if you second graph the calculator, you're going to be looking at 1 and 24, 2 and 12, 3 and 8. And all of those numbers add together to be positive numbers. I need negative 11. So in your calculator, you need to go up. You need to be looking at negative numbers. So when I go to my y equals screen and I do negative 24 divided by x, and I go to my table, I need to look at this. I need to go in the up direction rather than the down. I need to arrow my calculator to the negatives. Do you get what I mean by that? All right, so here's what you see in your calculator. That's all of them, because we'll start to get -6, -4, which is the repeat. All right, so I'm focusing in on the negative part of the calculator. Now that I do that, I am looking for numbers that add to the B term which is negative 11. So let's do some addition. What's negative 1 plus negative 24? What is it? Negative 25. Negative 2 plus negative 12? Negative 14. Negative 3 plus negative 8? Negative 11. Negative 4 plus negative 6 is negative 10. Right? So all of the numbers on my list satisfy C equaling 24. If I multiply them, I'm going to get 24. I need to add them and get negative 11. So which pair of numbers should I use? Negative 3 and negative 8. Once you have those two numbers, they go in the blanks. So I know that the format of all A equals 1 answers look like this. All A equals 1 problems start with an X and then they have some number, and then start with an X and have some number. Your goal is to figure out what is the sum number. Well, the number is minus 3 and minus 8. So because they're both negative, I'll do a minus 3 and a minus 8. And I could check this using y1 and y2 of the calculator, right? Or I could redistribute. X times x minus 8 minus 3 times x minus 8. I'm adding x squared minus 8x minus 3x. And a negative times a negative is a positive. And then a negative plus a negative is a negative 11. So I end up with the same thing I started with. You can check it by hand too. You okay with that so far? All right. Let's look at C. Step 1, we're checking for a GCF. Take my word for it, there is no GCF. All right. Now A is 1, because there's like a 1 in front. B is 2. And C is negative 15. It's a trinomial where A equals 1. We're going to use the A equals 1 method. Okay? The A equals 1 method says we go to the Y equals screen and we do the C value, which is negative 15 divided by X. Look for numbers in the table that are next to each other that add to B. Well, let's think about something. Let's go back to our number sense. My pair of numbers need to multiply to negative 15. If they're going to multiply to negative 15, what immediately is true about my two numbers? They got to be different. One's positive, one's negative. So I'm not necessarily going to the negatives in the calculator or the positives. I've got to look at both. Okay, so keep that in mind. If I needed to multiply to a negative, I'm going to have to look at both in my calculator. So, if you type this in your calculator and you look at the table, you'd see like a 1 and a negative 15. Next to 2 would be a decimal. Next to 3 would be negative 5. Next to 5 would be negative 3. That's not a repeat. Why is that not a repeat?
Because they're different.
The negative's on a different number. That's different. So if you keep going, you eventually would hit a 15 and a negative 1, right? Those are the only whole numbers you're going to see in your table. I'm only pulling the whole numbers. I need my C value, my B value to be 2, meaning I need these things to add together to be 2. 1 plus negative 15 is negative 14. 3 plus negative 5 is negative 2. 5 plus negative 3 is positive 2. 15 plus negative 1 is 14. I need positive 2. It matters which number's negative here. I could pick this one, but that's negative 2. That's not going to work. I need to do this one. The 5 has to be positive, and the 3 has to be negative. That's the only combination that would work. And I know in my factored form, I have these parentheses that start with X. The positive sign has to be on the 5, and the negative sign has to be on the 3. The order doesn't matter. You could put the negative 3 first, but the plus sign has to be with the 5. The minus sign has to be with the 3. X times x minus 3, positive 5 times x minus 3. add the exponents. X times negative 3 is negative 3x. 5 times x is positive 5x. 5 times negative 3 is negative 15. Negative 3 plus positive 5 is positive 2x. If you put the symbols the other way, you'd end up with a negative 2x, and it wouldn't be the same as when you started. So the symbols matter. You okay with that one? All right, last example we're going to do together is this one. What's different?
It's got to.
A doesn't equal 1, does it? All right, so if A doesn't equal 1, I want to try to make A equal 1.
Got easy.
There's a GCF here, okay? Let's think about the numbers that multiply together to be 2.
So,
1 times 2. The numbers that multiply together to be 2. 1 times 2. The numbers that multiply together to be 40. There's a lot of them. Is there a 2? Yes. So there's a GCF. Now, is the GCF 2 or 2x?
2.
Why isn't there an x?
Because 40 don't have.
They don't have x, right? That last term doesn't have an x. There's no GCF. All right, so we got to divide out the 2. Got that so far? All right. So 2 divided by 2 is 1. I'm not going to write that. I'm just going to write x squared. The 2's cancel out. Minus 2 divided by 2 cancels out. I just have x. Negative 40 divided by 2 is negative 20. Don't forget, when you divide out a GCF, it doesn't disappear. It goes to the front. All right, now, A equals 1. What does B equal?
1. Negative 1.
Negative 1. C equals negative 20. Now, if we ignore the 2 in the front, we can do A equals 1. Right? A equals 1, B equals negative 1, C equals negative 20. So I'm ignoring the 2, and I'm going to do a negative 20 divided by x. And I'm going to go to my table, and I'm going to look at the values. We've got 1 and negative 20. We've got 2 and negative 10. Nothing next to 3. 4 and negative 5. 5 and negative 4. 10 and negative 2, 20 and negative 1. Those are all my combinations. Those are all my whole numbers in my 20 table. What do I need them to add to?
1.
Negative 1. B is negative 1. So I'm adding them, and I'm seeing what I get. Eventually, you're not going to write all of this out, right? This is just your toolkit notes, so it's helpful to see it. I need the pair, I need the combination that adds to negative 1, because the B value was negative 1. So I'm looking at a positive 4 and a negative 5. So if I write that in factored form, remember we've got like the x's in the front, and we're just filtering in the number that goes with that. So that's a positive 4 and a negative 5. But remember that 2 in front. If you forget the 2, everything will be half of the value it should be. Because we got to multiply them all by 2, we divided the 2 out. So the factored form's got the GCF in the front, and then we use A equals 1. So it's possible that you need to use both methods. Are you okay with that? Tomorrow we'll just practice that. There's nothing new to it, right?
Wait,
So
so
the
that's
whole
it?
day, that's it, that's the answer, it's factored form. So the whole day in class tomorrow, we're gonna practice A equals 1 and GCF, okay? And then there are 2 other factored methods. We won't start a new one tomorrow, okay? We've got this new Math Excel. It's not due till May 7th, so we've got a bit here. But if you wanted to put a dent in it with GCF and A equals 1, there are 16 problems total for GCF and A equals 1, so you can start it. We've got plenty of time. You'll have plenty of class time too.
How many,
I think there's 25. Okay, all right, so we've got that Math Excel if you want to get started, but I will give you plenty of class time. You don't necessarily need to start it tonight.